and thank you for joining us for our very first Aitech virtual customer forum event. There's no doubt that we are all facing a new reality with COVID-19. And in this new reality, there are challenges such as AI in the future of battlefield and cyber threats that will accelerate in the post-COVID-19 era. That's why Aitech has decided to focus on these two topics today and challenges that we are all facing in our 2020 annual event. With that, let's go to the agenda slide that you can see here. And we will be covering a variety of topics today. So let's get started with our first presenter, Yaron Munn, who is the Chief Executive Officer at Aitech.
Hello everyone and welcome for our virtual conference. I would like to thank you all for attending us today and spending the time with us, and hoping to meet with you in person when we will do our conference for next year. I would like to take the opportunity in the next few minutes to introduce myself a bit, to introduce Aitech. I know many of you know Aitech for many years, but the company has been changed quite heavily in the last few years. So we will try to update you all what has happened in Aitech, and also to share with you the way we see our sector, the defense sector, in these strange days of mid-COVID, post-COVID trends and situation. A bit about myself, a bit more than 45 years old. I live in Israel, in Kfar Saba. I have 3 kids and one that additional one coming almost every week now. I joined Aitech a bit more than a year and a half. I graduated both my bachelor and master degree in industrial engineering from the Technion in Israel. My first work after graduating almost 20 years ago was in the production electronics line for automatic testing equipment in the defense sector. But since then, I moved more to leadership and management position. I worked in various industries, not necessarily only in defense or electronics. Most of my position were in global companies in various size and countries. I believe my main expertise is transition management and growth enhancement within the companies. I would like to start by sharing with you our vision. For me, a vision for a company is something that is quite significant, and each and every word matters. I believe you can read for yourself. I would like to focus on the first and last words. The first word in our vision is creating. I believe this is our main value, and that's what we do. We create systems, we create solutions. We have IP, we have knowledge. We are not just delivering, assembly, providing, integrating, or whatever. So we are creating solutions. And all of our solutions are embedded in our customers, in yours application and solution. And together, I believe we are securing a safer and a better tomorrow for mankind. We operate today in 3 facilities, US, Israel, and India. We have a bit more than 200 employees. We have a global virtual organizational chart, so we have one global leadership team with team members in all of the 3 countries. Basically, in these days, the place where you live doesn't necessarily affect the way you can do your work. In all of our facilities, we are capable for engineering, production, customer service and support, production. So we are fully flexible to meet the needs and the demands for the various needs of our customers. In these slides, you can see an attempt to summarize everything we can do for you. So we have identified our products line. You can see them on the left side of the slide. I will not read them through, but you should know and be aware that for each product line, we have a product line manager. 2 of them you will meet later on today. We have a roadmap, we have a technology and also production roadmap, and also mix of customized and off-the-shelf solution to support various needs. All of our product lines have application in all dimensions views, from space to land, sea, and air. We have built ourselves to provide a complete solution for 360 degrees for our customers. So as I said before, in every line and for each product, we have an off-the-shelf solution. We have a subsystem and semi-customized solution. We provide all kinds of support, from component engineering to customer support, program management, obsolescence management, all the certification and documentation needed So we are quite flexible, but we build ourselves to provide a full solution to our wide customer base. You can see here some relevant examples. I will share with you some customer data later on, so maybe we'll move through. We have defined core values of the company that we quite strictly implementing both inbound and outbound of the company. Our passion to win and our passion to help our customers win their challenges and win their business. Creativity, both in our technology and in the way we do business. Respect for each other, but also for the whole ecosystem and environment. And last but not least, a very strong level of accountability all across the board. Now I would like to take a few minutes to share with you the way we look at trends in our industry. So the way I see it, we are living in a time where there are two strong trends that are affecting most of our industry situation. The first one is a technological revolution of the military conflict and the military field. That trend has started a few years ago, but we see it grow stronger and stronger. And the second one, of course, is the effect of the economical and health aspects of the COVID-19 situation and all sort of estimation about what will happen in the near future. So if you look at the anonymity of military conflict, what we can see is a very strong focus on equipment modernization and not necessarily new equipments. We see growing focus on unmanned solution, both for ground, air, and space. Cybersecurity become an issue because of the unmanned vehicles that are traveling around the battlefield. Stronger and more sophisticated AI application, biological threats, use of robotics and small robotics. We see space becomes more and more relevant also for defense application, and especially the LEO, the lower space orbit. And everything has to be smaller, lighter, and faster, and I think we can all understand why. If we look about the effect of the COVID situation on our economical, so first thing to say that at least until now, global spending in defense remains stable, so we haven't seen a big decrease. Also forecasts for 2021 seems the same, but we all have a very high level of uncertainty, so that might change. Even though the spending is stable, the competition level is increasing for various reasons. I think one of the main reasons is the defense side became more attractive because the commercial sides of aerospace, as we all know, has less spendings and fundings. So companies in the past tried to compete in both arenas are now putting all the focus on the defense side. We also see an increased use of open system architectures that also supports the level of competition that is increasing. Lack of cash make the focus on modernization of equipment even stronger. So more and more governments will invest in upgrading a platform rather than introducing new platform to the market. Cash being spent on recover from the COVID might require new ways of fundings. So I think all of us will be forced to be more creative in the near future, and supply chains becoming an issue. So more and more companies, especially the main defense consumers, governments, are trying to localize as much as they can. Lockdowns and shutdowns and all that, creating a much stronger need for flexibility and agility within the supply chain. So supply chains for sure will be the first things that will see significant in our industry in the very near future. I would like to summarize by saying that when we look at the challenges and the trends and the legacy of Aitech, we believe that we are fully ready to meet those challenges and also to support our customers to meet their challenges. We have decided to use some numbers and not words to demonstrate why. We are investing a lot of money in R&D, double-digit percentage of our revenues every year in the last 20 years. We have delivered more than 100,000 of boards. We are growing, again, double-digit for almost 20 years now. So we have a high level of confidence that together we can succeed in moving forwards, even though we have some low-term challenges. Thanks again for joining us. Hoping you will have an interesting and fruitful seminar, and hoping to see you in person very soon. Bye-bye.
Through customized, COTS or using COTS does not mean you're giving up on any capabilities. In fact, by going through the solution Aitech offers, You get faster deployment because you're building on boards and products that have been designed, have been tested, and in many cases verified, and are able to combine these boards and capabilities into a system. It's lower risk simply because our boards have been tested and verified over the years, and as well have flight pedigree. They're affordable. The cost for NRE is kept to a minimum. And the modular card solution allows you to build a system based on the right combination of capabilities. And then ultimately, our solution is proven and reliable. Over the 30 years and the missions that we've been on, we have added up a lot of flight time. We've calculated somewhere over 150 years of cumulative space flight experience with our boards, components, and systems that have been flying across LEO to deep space, which counts to trillions of miles flown in space without a space failure out there. So COTS for space provides a great deal of flexibility, a great deal of cost advantage, but you don't forego any loss of benefits going custom. You get the best of both worlds. So with that, I'll return back to you, Renee.
Thanks, Pratish. Pratish covered some of the affordability in space. And now I want to transition and invite our next speaker, John White, who is the Space Product Line Manager, to go into more of our COTS offerings and how we can best provide them to our customers. John?
Hey, thank you, Renee. Let me, I'm trying to turn on my presentation view. I hope everyone can see that. I'm going to be talking about basically our product lines and how they're positioned in the space market. We will start by talking about our SPD-S system, which Pratish had shown a little bit earlier. I'll talk about our custom space electronics and a fairly new product that we have. We call it Ai-RIO. And so let's move on with the SPD-S system. So the SPD-S system, as Pratish mentioned, is a single board computer with many different IOs and communications and memory peripherals that you can add to it. They're generally enclosed in enclosure. We have multiple different enclosures to choose from. But it's a lot like when my son was starting to get interested in building computers. He went to Fry's. We bought a motherboard. We bought the peripherals that he wanted to do for gaming, and which included a video card, some memory, and some additional go-fast things. And we put the computer together, added in an operating system, and we were off and running. And he started his career in building computers. In addition to the cards that you saw, we have multiple enclosures that you can choose from. All the enclosures come with space-rated power supplies. We offer 2 different kinds of power supplies for 3 volts, 5 volts, 12 volts, 15 volts, whatever system might need, we can supply that. And we go from 2 slots up to 8 slots, which is the limit for CPCI backplanes. So we talked about a little bit about that we are kind of like Fry's to the people who build computers, want to build a space computer. And so I want to go through the nuts and bolts of how to actually do that. As Pratish mentioned, by using COTS hardware, you can you take advantage of proven reliability, proven environmental performance, proven mechanical performance, proven radiation performance. On our flight products, the parts that we use are qualified and upscreened to the EEE standard or installation instructions 002. Which gives high reliability and quality control. And we are a full AS9100 compliant facility, as well as our subcontractors. So all of that is embedded in our COTS hardware. So when you come to Aitech to buy COTS hardware, you're coming, the hardware that you're receiving has all of this embedded. And that's really the big value in using COTS in the first place. So I said we're going to have a little bit of nuts and bolts demonstration. So if this is a little bit elementary, I apologize, but it really is simple. So say that you're building a Earth observable satellite, which is my little picture on the right-hand side. On that, this diagram, the satellite bus diagram, I just pulled off the web. So it's any bus diagram that that could be yours, or could be something that you're thinking about. And it has a optical payload, and it has bus controllers for power control and propulsion control for altitude, or maybe navigation. And there might be some mission processing as well. And so everything that's in the green box is what we are going to attempt to build using COTS hardware. So in that subassembly that I just mentioned, it would include a computer, it would include a frame grabber, a memory board so you can do image processing and storage, and an enclosure. You'd also need to have I/O to your communications link, your pointing and focusing for your camera, avionics link to know where you're going or where you've been, and propulsion control for station keeping in your satellite. So the way that you'd start is that you'd go to the Aitech website. And here I just have a picture of what you would find if you clicked on our space products and looked for single board computers. And you will see that you have a selection to choose from. And so if you click on the single board computer, you find that we have what we call our SPD-S, which is our fully space rated single board computer. It has many IOs and many capabilities. It's a CPCI backplane. It's been flying since, or it's been available since 2012, and it's been flying since 2014. So if you went to there, you'd see that you have the SP0S, and you combine it with the operating system, and that's the picture that you see there. For the frame grabber, we would choose the S945, and that's a picture of it there. You'd choose memory S992. Unless you were going to the moon, you'd choose the S993. And then finally an enclosure, which is our E902. It's our smallest enclosure for the CPI backplane. It has a minimum of 2 slots, but we can grow that to 5 slots. And you can see the interfaces that are going to be talking to the things that are the payloads and the navigation and control buses. So in this diagram, I say that we're going to use the SP0S Ethernet port to talk to the communications subsystem. We're going to use the RS422 to talk to do the pointing and focusing control for the camera. RS422 also for the avionics data, and then finally a propulsion control also on RS422. In this diagram, and what we have seen is a lot of our customers want to have high-speed connection between the image processing and storage. We can do that across the CPCI backplane as shown, but a lot of customers are asking for PCIe interfaces to make that much faster. And then a space wire is available on the S945, as is camera link and other standard camera communications. And you can use a space wire, in this case, space wire to upload the images from the camera. So by using our website and having an idea about what you need for the hardware to build your C&DH system, you can build a custom COTS system like Pratish was describing. So this gives you a standalone system. Its benefits are that it's all built from space qualified hardware, meaning that it's radiation tolerant. It'll meet the environmental requirements. It has the reliability for space products that's required by NASA. and it comes in a much more affordable price, about 1/10 of what a custom computer would cost with those interfaces. We have offerings for higher level of components as well. So if you're in, so we satisfy the mission requirements for reliability and quality as well. So that's our SP0S system. I want to talk a little bit now about our payloads electronics. We have, excuse me, custom space electronics. We have a number of different build-to-print type products that we could leverage off of to build anything that any of our customers would like. A lot of our customers need special communication protocol converters. So, for instance, what you see on the right-hand side is an Ethernet media converter. This actually converts 1000 base T to 1000 FX, which is your fiber, and 1000 base CX, which is your time-triggered Ethernet. So this is actually used in the Orion spacecraft, and likely be used in most of the lunar programs since the standard Ethernet protocol on Halo and HLS is 1000 base CX, the time triggered Ethernet, and most hardware is a 1000 base T. So they'll use this type of media converter. We also do power distribution and control of arm and fire protocols for release mechanisms. We do other communications from, say, camera link to space wire. These are, like I say, all custom electronics. What the value is to our customer is that they're getting a custom piece of hardware that has all the radiation tolerance, reliability, screening, and qualification of parts, and all the high level of quality that you would expect for space grade products. And this can and we usually draw from parts that we already use. So in a lot of ways, this is almost COTS, except for that it's custom defined by our customer. The last product line that I'd like to talk about is our Ai-RIO product line. Our Ai-RIO product line is a space qualified communication and data handling system. The great advantage of this is that it's swapped optimized, so it means that it's smaller than our CPCI backplanes assemblies. It's lighter weight, and it uses less power, and it comes at a relatively low cost point for the amount of functionality that it has. What gives this system a lot of flexibility is that it has 2 FPGAs that allow it to have multiple and various communication protocols, ins and outs, and it can do communication conversion as well. So that makes this an ideal candidate for a payload interface, for example. So you could have, in fact, what's becoming more popular especially in commercial space, is to have multiple payloads. So they're basically doing payload sharing, much like space launch vehicles are doing payload sharing. So it's a way of reducing cost per payload. So the satellite would have not just one payload, but it could have 4, 5, or 6 payloads. And so this would allow you to communicate to all 6 because of its communication flexibility. And then it can translate all that data back to the system controller for the satellite bus. The way that the Ai-RIO that I've shown in the picture is really shown in the upper right-hand corner of the slide here. It consists of a power supply module and a CPU module. The CPU module is actually shown on the bottom, a picture of it shown on the bottom. And it has it provides the heat sink. The case itself provides the heat sink for the controller board, and then there's a connector in the back that you can barely see, but it's the I/O between different boards. And in this case, the case shown in the upper right-hand corner, it's the communication to the power supply. But the great thing about the Ai-RIO, much like the SPD-S systems, is that it's expandable. So if we had a customer who wanted to have additional communication that we didn't provide, we could add a slice. And so that could be what's shown on the bottom is it's a center section between the CPU module and the power supply that allows it to expand to add additional functionality, memory. We add in one system, we added a second controller board. So it had 2 controller boards instead of the 1. Each controller, and for that particular system, they needed 6 space wire ports. Each of our controller boards have 4 space wire ports. So this gave them a total of 8, which they ended up using 1 more because it was there. So again, the Ai-RIO product is really highly versatile in communication. Makes a great payload interface to the system bus, and it's expandable for a whole bunch of functionality that the customer might need. I wanted to also talk a little bit about our product ruggedization levels. We have 3 different levels. You'll see this on the website, and I just wanted to show this just to introduce the audience to it. The reason why it's important is that it allows the different levels allow customers to do concurrent development while we're working on the finalization of a system if they were doing a custom system. So the first level is the space for our space ruggedization is our Series 100. Basically it's an air-cooled device. It's functionally equivalent to the full flight boards and cards, but it's air cooled. It's not, and it doesn't share the same physical features. So it could be different size, different shape, different envelope, and it certainly doesn't have the same environmental performance and mechanical performance as the full space qualification. And what customers will do is that this is a low-cost functional unit that our customers can develop their software and their system controls on, while again, like I said, we might be building a custom board for them or something that is unique that might have a longer lead time. I want to jump to the most right-hand column because that's the most obvious second place to go. That's a Series 500, our full flight products. Those products are rated for full vacuum, rated for most to have a temperature range that is more than what most of our customers would ever use. It survives, you know, it's rated to or it's built to survive launch conditions, and also for it's designed also for full vacuum, and additionally, this would be used. These products would be using the full space rated components on the board. So they're the Series 500 typically use EEE parts per the NASA standards for high reliability, for radiation performance, and for quality control. And then in the middle, and it's not just spatially in the middle, but it's also functionally in the middle, is the Series 200. The Series 200 is a flight-like system. It uses the same printed wire circuit board as the Series 500, but it may not use all the same parts. So where we have a full space rated part on the Series 500, we may not use that for cost considerations and delivery considerations on the Series 200. And I mentioned that the Series 500, all the parts are rated to level 2 on per the NASA standard. Our Series 200 are basically those parts, but without the qualification and upscreening, which reduces their cost. So roughly speaking, the Series 200 is about half the cost of the Series 500. And its purpose is to do ground level integration testing. So our customers would take this unit, install it into their hardware, and then do all the and then load their software and images onto the system, and they can do a full functional test in qualification testing on the ground. And in some cases, our customers will literally do some. They'll take these Series 200s, do their ATP on their vehicle, and they'll replace the Series 200 with the Series 500 and deliver that vehicle then for flight. So it gives us a lot of options and different affordability levels for development, and especially to aid concurrent development of software while the hardware is being built. And last, I want to talk about our COTS lifecycle program. This is 3 phases, all 4-year phases. We have an active phase, a supported phase. In that phase, we'll support any customer's request for repairs or upgrades on equipment that they have bought. And then there's an extended support phase, which is another 4-year period, and that's negotiated when parts start falling out of where we can't get them anymore, when they become obsolete. Wanted to point out where you might find our products: the satellites, launch and landers, and habitats. We go by each of these quickly. The green on the right-hand side, the green boxes are the subsystems that we supply hardware to. Some of this, or I should say, we provide the fundamental hardware. The blue boxes are systems that we might provide some hardware, and you can see on the left-hand side where that hardware actually might be. So for a satellite, we provide the frame grabbing payloads, payload support, release and initiation for hold down mechanisms, power regulations, and you can see a multitude of the small sat payload support we provide for that, as well as some of the power control. For launch and landers, we provide tracking and acquisition. We did that on Orbcomm. We do flight control computers on Spaceship One, shown there. We did a data logger, which actually helped to find some of the problems that resulted in its failure, flight failure. And then we also do the full flight control computers for we're planning to build for the lunar landers. So from manned to unmanned missions, high reliability to low reliability requirements, we have hardware that can cover them all. And lastly, the habitat segment, so ISS and HALO. There's a lot of subsystems because you're supporting manned missions. But we are offering full systems, but like I say, we're involved in a lot of the boxes that are blue here for guidance, power control, data acquisition, communications, and whatnot. So that's it for me. Back to you, Renee.
Thanks, John, for covering our commercial off-the-shelf offerings, both currently and for future programs. I now want to transition and invite our next speaker, Aiman Kadumi, our Director of Research and Development here at Aitech US, to discuss the future of space technology. Aiman?
Yeah, before I start out with the presentation, I would like to introduce myself. I just started here 5 weeks ago with Aitech as the Director of Space R&D. This is a role that most of the audience probably, some of them are previous colleagues in my 23-year career with NASA, probably are surprised to see me doing. But it is an exciting opportunity, and it came out as a result of a vision that Yaron has shared with all of us, where technology at its best and the customers are driving that technology for us. And we saw an opportunity here to do both. So let me delve into real quickly about our market segments. Mostly, as you know, satellites, as John has mentioned, as well as orbiting spacecraft and stations, lunar landers, deep space habitats, interplanetary satellites and missions are pretty much our target market, and has been for quite a while, and we have proven our excellence there. However, the new market, the new Space 2.0 has shown us here that the next 10 years will not look like what it used to be. So we are preparing ourselves for that, and we are hoping that what we bring to the table will meet those challenges and those requirements. 1,000 satellites and more by 2025 brings its own requirements and its own challenges and risks, and we are hopefully prepared for that. As you see, the COTS-based idea, or at least core competence that we bring to the table, will still be present because we need to support that for also fast deployment of the systems. Most of the missions right now require us to do this in a 2-year period. For instance, I came from Intuitive Machines 5 weeks ago, and we're working on a lunar lander. And we know that they are working on this furiously, and they need all these systems to be deployed with a very short life cycle, development, production, and the whole thing. So this is where we come in, and hopefully what we provide here, as you see on the screen, will be able to meet these challenges. The R&D center, when this was brought up, was where can we have an R&D center that will serve our needs and our customers' needs? And we chose Houston, Texas. We think that what it brings to the space community, Houston, that is quite a bit. The spaceport, the initiative that they're starting there, the commercial labs that belong to commercial companies and newcomers and pioneers in their fields have chosen Houston as well. So we're going to be nearby and supporting our customers there. What is R&D? What is the value to our customer? I think that you have seen so far where Aitech brings as pioneers in their own fields. And they have invested quite a bit of money now and funding into supporting the internal R&D efforts. And we don't want to let the gas on the pedal go in a sense, because we need to keep pushing to push the state-of-the-art technology that we're seeing today, and to help us advance it for the needs of the future space and the spacecrafts. So our work with the engineering team, with the production team, will be extremely important as we try to spearhead the development of the next generation of COTS in space. There are certain trends I will mention here too that we think are driving the space industry. One of them is where our customers are requiring now the vertical integration of not just boards, but also subsystems that are built, and the core of these are pretty much what we call the we have mission computers that will drive larger missions, but we also have mission computers that will drive smaller missions, and they come with different requirements, obviously. John talked about the Ai-RIO as a platform. We will, in the R&D, we will expand that notion, and we will offer and enhance the multifunction capability that it brings. And we feel that with our customers that need multiple payload support, especially enhanced fast performing bandwidth and storage and memory requirements, These are needs that we will meet on a small level, and the Ai-RIO will meet those, especially in the satellite constellation world. When we talk about the larger missions and the larger computers, the mission in a box is our mission-ready system. This is more of an abstract idea, obviously, but when we talk about the processing, we're talking about our heavyweights, the next generation, similar to the SPD-S, what we bring. These are the, so it could be Intel-based, it could be GPU-based, it could be a combination of both. But we're offering a mission in a box that our customer who is looking for that short cycle, life cycle, will be able to find this as a gift wrap almost. Because out of the box, hopefully it'll solve some of the requirements that they need. For instance, a lunar lander will require more GNC functionality, and they will be asking maybe for optical navigation systems. And so that mission will be customized in a way or geared towards doing this. However, we recognize the importance of COTS in this, so we will make sure that this product will be built in a way that will support that mission. And as you see, we have put in some features here, might be lofty, but we think will help in the system level tolerance and redundancy that our customers are seeking, as well as the management of the thermal and radiation protection that and the radiation that they're looking for. We offer the AI Health, the AI Secure as well solutions on software editions. We also have PCIe networking wrapper we call Dolphin that we will also be introducing. There's a lot of things that are happening, and as I work towards making this a reality with the teams back in California, I think that we could have a good system level of products that we can offer for our customers. I could talk about Space VPX and our VITA 78 SOSA compliant products. As we know, the market has changed quite a bit right now. We serve markets that are different in nature. And therefore we have to make sure that the advantages that Space VPX brings in terms of performance, in terms of reliability and reuse, these are the kind of things, and the flow of data and the customization that is not needed to do at some level will be very helpful in these efforts. Of course, like John said, we will still support the functionalities that we do in terms of time-triggered Ethernet, deterministic systems. One of the bigger things that we're looking at right now is introducing AI and edge computing into the mix of what we do. We recognize that these long duration missions will require onboard computing to be, or onboard processing, as well as data fusion to be done on board. And this way it'll minimize the network bandwidth and the return to Earth, and in terms of battling for resources. So I think, or we think that this will be definitely a solution or to a trend that we're seeing right now. We talked here about what does it mean in terms of the next gen enabled technologies, and as I mentioned maybe a little earlier, where the CPU GPU combo board can replace a flight computer and a vision processing unit, a VPU on a spacecraft. If you're currently developing this technology for a customer, this will be featured as one of our main products. We also recognize the need for large bandwidth usage, and the fact that most of these missions don't have line of sight, whether it's satellites or whether it's some other missions, and will be used something like delay tolerant networking, where you're going to require, where you can have large amounts of storage that is needed, as well as memory. So we would be pushing the boundary on these. We're working with vendors as well as partners in this field, and hopefully we can bring the best and the latest into our efforts as well too, and hopefully translate that into products eventually. And that's it. I think if you need any other questions that can be answered, sales will help, and And I am sure that later on we'll share with you the contact information from all of us. Thank you for listening, and we'll talk soon. To you, Renee.
Thanks, Ayman. Now I want to introduce some of our experts for our Q&A session. So we have a few different questions that I'm going to be asking our panelists to answer. Our first question is going to be for Pratish Shah, our General Manager at Aitech US. As a company that provides rugged solutions for both military and defense applications and space applications across the globe, can you please elaborate on how Aitech has established itself in the satellite technology space?
Thank you, Renee. Yeah, so I mean, Aitech has a fairly long history of providing ruggedized COTS solutions and boards and systems for our national defense and security, air, ground, and naval forces. Space is the logical next frontier for our commercial as well as for defense industries. And, they face the same challenges that our military and defense industries have faced for decades. So we started space, COTS in space, as mentioned, about 30 years ago. And it's exciting to see COTS in space, becoming a key enabler for space, boom that we're seeing today. And we also see an insatiable need for high computing performance and systems in space environments. And the next logical step for us, has been to continue to expand our COTS capabilities and expertise to the space market. And for us, this covers all the domain from space, deep space, to LEO, to high altitude, to air, to ground, to sea, and underwater. So for us, COTS technology and COTS systems, across all these domains is their natural course. So. And we're excited to be able to support that expertise for our space customers. Thank you.
Thank you, Pratish. Our next question is for our product line manager, John White. John, what are the market pain points for our customers, and what has manifested as opportunities in our solutions and approach?
Well, thank you, Renee. It's a great question. A lot of our customers, they come to us. They have a idea about the kind of system they want. It's generally a high performance system requiring high level of processing performance, memory, certain IOs, usually a lot of IOs for a lot of payload interfaces. And so that typically kind of makes our systems a little bit complex, and so they'll be wanting, they actually, a lot of times they come in thinking they need to have a custom system built for them, when in fact as I demonstrated, there's a COTS equipment available to support that mission. And lastly, they want something that's space tolerant. They don't want to have to go through radiation testing because it's very, very expensive and takes like about a year to do a test on one part. They want something that they can have confidence in, that's going to perform the first time that it flies, because they can't, like I did with my son, when we, like I mentioned earlier, we went and built a computer. We can't go back to Fry's and buy the right part or the second part or replace the part that was bad. The systems that go in space have to work the first time and have to keep working for the full mission. So these are the concerns that our customers have. What we've done is, by offering COTS products, we give them the confidence that not only is it radiation and environmentally and mechanically sound for their environment, but we can do it at a low cost entry point, and also do it by using COTS products. We do it without having to do custom designs. And when we can take advantage of creating a custom system out of our COTS hardware, our customers generally have hardware in less than a year and ready for flight. And what the big advantage for that of using that COTS hardware is, they have, in many cases, the hardware that's inside the box that we deliver has already been flight proven and has flight pedigree, not only flight qualification. So that's the big enabler. And in the times where we need to have a custom board, many of those custom boards end up becoming our COTS products. And so the more custom hardware we build, the bigger our COTS offering becomes. And so that's where our customers get the biggest advantages. They can take advantage of other people's developments using our COTS hardware, which assures them that they're going to have a high performance system that meets their payload interface requirements, and also all the space ruggedization and qualification and pedigree. And so that's where our customers can really benefit. Thank you, Renee.
Thanks, John. Our next question is to Eamon. Eamon, how has Aitech delivered top solutions for satellite technology in space? And what is the position to march ahead in the same fashion for the future of space technology? Can you provide us a sneak peek as to what lies ahead for Aitech?
Sure, Renee, thank you. Yeah, that is a very good question. Most of the industries, as we know, and especially our customers lately, seems like they have been asking for more processing, more I/O, integration, faster delivery, higher volumes, the whole shebang. And but we know that these systems are not going to be able to withstand the rigors of space and radiation and meet the processing demands of that higher data throughput. So we're hoping to leverage those decades of us understanding this, and this will definitely uniquely position Aitech to grow with the needs and requirements of the customers. And I think as far as what is ahead coming, to give you a sneak peek, I think my presentation was probably alluded to some of these things. But to give you a good example is right now today, we have a 3U compact PCI system, which is a common accepted platform for space missions. And Aitech, as you know, is leading in that field right now. Other than NASA and the civil programs, the COTS products from Aitech has been leading that field. But it has a speed limit, and it has a memory concerns. So these are things that we need to make sure that we match. For instance, in terms of speed, these are things that we need to look into. Research faster backplanes. We talked about VPX and what that brings into the table for our customers and what brings for us. And these are things, maybe Renee, that you will be hearing about a whole lot more as we talk R&D and engineering at some point. So all this is going to come into play, and like I said, we have right now 64 gigabit memory board. That will have to work with our chip suppliers to provide us a whole lot more than that in order to be satisfying the needs of our customers going in the future, whether it's satellites or other missions as well through the whole space market. Thank you. Back to you, Renee.
Thank you, Eamon. Our fourth question is going to be for Duke Tran. Duke Tran is the Aitech Vice President for Global Marketing. Duke, how do you keep track of the right ingredients that you wanted to have to build a relevant solutions portfolio? How do you make sure that our offerings help organizations to understand real-world applications and how to fulfill them?
Thank you for the question, Renee, and hello, everyone. We take two approaches to do this. The first approach is with conversation with our customer, and it's not simply a matter of asking our customer what they need. It's about engaging in conversation and understanding what problem they're trying to solve. You always start with the problem they're trying to solve, and we work with our customer to try to solve the problems. We've been doing that for a better part of 3 decades. And some of the things that we try to understand with conversation with the customer and their evolving requirements is that we talk about mission operation requirements. We talk about mission duration, the environmental that they operate in, the mechanical requirement trends, and all these things to try to have a good understanding of the requirements so that we have a good insight into the needs of our customer. Also, we stay engaged with satellite operators, builders, subsystem suppliers, and through all these conversations about solving the right problems, we're able to have insight into the future. So that's one approach. And the second approach is attending industry events. Satellite conferences, technology expo, Having said that, we haven't attended any or many this year, thanks to COVID. And so we start to move towards more virtual attendance. This is why we have these customer forum, exactly why you guys are all invited to this customer forum, is to engage in this conversation. This is not the end of the conversation. This is the start of a conversation. That's why we invite you guys to join us, to have this type of conversation, to ask us questions, and we will having many more conversation with you guys after the event as well. So the whole kind of industry events, it's moving virtually. We're hoping sometime next year, everything goes well, by mid next year, we can start to have physical events again and meeting you guys directly. There'll be a great way to continue the conversation. And this is through these multiple conversations, this is how we're able to have good understanding of the requirement in the future. Or on top of it, we are doing our own R&D research to make sure that we also know what's, it's a two-way dialogue with our customers, not simply a one-way dialogue. And the result of all of that is we end up having a complete building block portfolio of COTS product, and that is cost effective and reliable for the space applications. So those are some of the couple approach that we take, and we will continue to do so in the future. Thank you.
Thank you, Duke. Now I would like to close our experts panel and go into our speaker breakout from Michael Kaplan from Kaplan Astronics. And he will be covering the search for life in our solar system.
Here are two images showing changes on the surface of Mars, images taken from Mars Global Surveyor. And as you can see in the image on the right, taken 6 years after the image on the left, there's evidence of some sort of change on the surface. Astronomers believe that that was an outflow of water from the surface. Next, let's look at a series of rovers that NASA has flown to Mars over the last 30 years or so, starting with Sojourner, Spirit and Opportunity, Curiosity, and the most recent rover, which is scheduled to land in February 21, Perseverance. As you can see, each one of the rovers has increased swap, which of course provides much increased capability. Here's an image taken of Curiosity's descent prior to landing, taken by the Mars Reconnaissance Orbiter, a remarkable image. And now let's learn a little more about Perseverance.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration of Mars.
Very exciting new project. So Perseverance is due to land this February. And the question I have to ask everyone is, are we ready to find out what's really happening on Mars? Next, let's look at ocean worlds in our outer solar system. First, let's look at Europa. Here's the first image of Europa. This is a drawing that Galileo made in the mid-1600s when he observed 4 bright objects orbiting Jupiter with their configurations changing over time. He's the first person to have observed Europa. And here's a more recent image of Europa taken from the Galileo image, from the Galileo. And now let's look at what's ahead for Europa.
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. And we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa. But Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers and we didn't want to be too close to the sprinkler head. So we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes. We could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond.
Lastly, we'll talk about Titan. Titan is a moon of Jupiter, of Saturn, excuse me. Here are some images taken of Titan from the Cassini-Huygens probe. And the last thing I'm going to show you here is a mission called Dragonfly, going back to Titan, this time with a UAV.
NASA is pushing the boundaries of human knowledge and expanding the limits of technology. I am proud to announce that our next New Frontiers mission, Dragonfly, will explore Saturn's largest moon, Titan. Dragonfly will be the first drone lander with the capability to fly over 100 miles through Titan's thick atmosphere. Titan is unlike any other place in our solar system and the most comparable to early Earth. The instruments on board will help us investigate organic chemistry and search for chemical signatures of past or even present life.
So we have on Titan opportunity to observe the processes that were present on early Earth when life began to form, and possibly even conditions that may be able to harbor life today.
One of the things that is particularly exciting about this mission is that we can do the very detailed chemical measurements, but be able to put them in the context of Titan as a system.
It's the science that really motivates us to do this exciting and difficult mission. Go Dragonfly.
Always exciting to see where some of these products are going, both currently and in the future for space exploration. And to close our session today, we thank all of our customers for joining for our presentations, for our Q&A session. What we really want to get out of this experience is to really make sure that Aitech is providing our customers with the best solutions possible for your missions and your requirements. I now ask you to fill out the customer satisfaction survey, as your feedback is vital to our team to make sure that not only our products are for your requirements, as well as making sure that when we have next webinars in the future, we can best tailor them to your needs. Please fill out the customer survey and enter to win a $100 Amazon gift card that we will be announcing after the event. Thank you for your participation. Thank you for the Aitech team for this webinar and all of the people who put a lot of tremendous hard work into the webinar planning. Thank you very much for a successful event and have a good day.